Hey, what's up? Pop, 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 another server drop. What's up, players? We're going to be doing another one in our series for Pop, 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 another series drop. Essentially, the series is for teaching different hacking techniques by using CTFs. In my opinion, I think the capture the flag war game style is the best way to learn how to do different hacking techniques and how to practice and get good at what you're doing and come up with methodologies. My goal is to be a little bit different than some of your normal CTF write-ups, where I'm going to actually kind of explain the methodology behind or the workflow of what we are doing to pop a box. And also, like when I run a command or a tool, kind of explain why would I use this tool, why would I use this command, why would I use this switch, that sort of thing. So that you can have a better understanding instead of kind of moving the way of script kiddie kind of style into more of, okay, I want to know what's going on. I want to know the complete picture of why we're doing this and how this works kind of thing, okay? So today we're going to be screwing around with something that was very famous for quite some time called Eternal Blue. And this one here, if you're not familiar with the history of it, the NSA had been hacked and some of the tools were stolen by this group called the Shadow Brokers. And one of the tools was this particular exploit. And this exploit was also used in the Wannacry ransomware. So if you did a Google search for Eternal Blue, you'll see different things come up about it, such as the NSA developed it and lost it. And then you'll see here MS17010, which is the Microsoft one, because this was against a Microsoft system using SMB. And SMB is typically the file sharing protocol, if you will. Well, it's used to share files between different computers. And the SMB side of it is the Windows side. And then on the other side, for like Linux and Unix and other ones, they typically use something like NFS. You may also hear SMB called CIFS. That may be another thing. And it typically operates on ports 445, more than likely, but also you may see 139 pop up as well, TCP on both of those. So anytime they're using this Eternal Blue, it's essentially meaning that the SMB version 1 is in play on that machine, and there's an exploit for it for a buffer overflow. In this case here, we'll take a look at the Avast one here. This is pointing specifically to the MS17010. And if you're not familiar with these are what they call security bulletins from Microsoft. So when an exploit happens against a Microsoft machine, they'll put out a security bulletin talking about patches and talking about workarounds if possible, that sort of thing. So you can see right here, it attacks the SMB version 1 protocol, in this case here, for file sharing protocol on Windows. Now you may also see the terms Samba. That means the interoperability of this with Linux and Unix. But we won't focus on any of that today. So you can see here's the Shadow Brokers team that went ahead and grabbed all those particular exploits. And it was kind of found out real quick that the NSA was using these to attack different machines to be able to get full access to it. And that's what we're going to do today, is we're going to pop a box by using this particular exploit. Now, again, this is just in the name alone will kind of tell you this is what it's for. But we're going to try to approach it from the fact that we really don't know what's on the machine, but it's Eternal Blue. All right, so here's my IP address of my victim machine. I'm using the Try Hack Me room called Blue right there. And I think that's a free one, if I'm not mistaken. I think you should be able to get into it as a free room. So I'm going to copy that one. And the first thing we always do whenever we're starting this sort of capture the flag is we run an nmap scan. Nmap is a tool to be able to scan ports. So I'll explain more about what we're doing after I type the command and run it, because it's going to take a little bit of time to run. So I'm going to do nmap tac n tac capital PN. By the way, when I say tac, I mean dash, and tac capital A, and then the IP address. All right, so what we're doing here is I have a video specifically going over nmap and all the different types of switches and how to use it and the scripts and all that kind of stuff. So I would reference you to that to get more knowledge on it. But the summary of it is there's 65,535 TCP and UDP ports in a computer, and the computer is accessed via these ports, kind of like a door, if you will, as a layman's term. And some of them are well known, like the first 10 through 1023, because 0 is considered one of those. Those are going to be what they call well-known ports, things like port 80, port 443, port 22, things like that. And then after that, we have up until around 40,000 or so is going to be what they call registered ports. And then after that, 40,000-ish number on up to 65,535 are going to be called ephemeral or dynamic ports, which are ones that are opened up on your client machine communicating with the server. So the idea behind ports would be, I'm a client computer and I have a server that I want to reach of an unencrypted web server. So therefore, that web server is listening on port 80, okay? I, as a client, connect to it, and it randomly chooses a dynamic port from my client computer to represent my computer, so that the request that comes back from the server knows exactly what port to send it to. It's going to pick one up in that range, like 40,000-ish on up to 65,535, okay? That's kind of the idea here. What we're doing with this is we're scanning ports on the victim machine, in this case the server, and we're looking to see if there's any open ports that are of interest to us as a hacker, so that we can see if we want to go ahead and blast into them, probe them a little further, find out what's going on. Nmap is kind of the de facto tool that almost everyone I know uses, but there are some other ones out there like AMAP and a few other things. And I tend not to like the GUI version, the ZenMap one, so I always stick with Nmap, the command line. So what I'm doing with the TAC-N is I'm skipping DNS resolution because I want to kind of speed things up. I don't really need the DNS resolution for this. The TAC capital PN means, and by the way, it's case sensitive in Linux, so you do have to do the capitalization. This is basically saying don't use the ping, because there's a lot of machines out there that will kind of drop the probes because they disallow ICMP, which is what the ping packet works on. So I just say skip all that nonsense. And then scroll back up here. The TAC capital A is a switch specific to Nmap, which runs 4 different things. First thing it runs a version scan, which is TAC S capital V. And what that will do is it will say, okay, you have a port open on, let's say, 135, or let's just say this one here, 445. And the service is this Microsoft DS. But I don't know exactly what version you're probably using. Nmap has a massive list of different probes that it will do, and if the machine responds in a certain way, it will look up those probes and see if they can get a match. If they get a match, they can usually get it right to say, this is what it's running, right? This is the version it's running. We need that from an attacker standpoint so that we can look up an exploit specific to that version, okay? So in this case here, this is checking all the ports. Now, keep in mind, I didn't include, I'm sorry, let me finish the TAC-A. So the first thing it runs, like I mentioned, is the S capital V. Then the next thing it will do is an operating system scan, so it can find out, well, what's the operating system that it's running. And then down here, it may not give an exact OS match, but as you go down a little further, it may kind of say what it may be. We're seeing a lot of Windows 7 Professional here, Windows 7 Professional. So we can kind of gather it's probably Windows 7 Professional. And the other thing it runs is S capital C, which is the default script scan. So Nmap has a scripting language, and the extension is .nsc, but the language is Lua. It allows to extend the functionality of the port scanner beyond just doing port scan, and it can do other things like exploits and all kinds of cool stuff. So there is a default set of safe scripts that it can run. By safe, I mean it's not going to blow up the machine. It's not going to cause a lot of noise that will get you necessarily found out, right? So it's not entirely that intrusive. So it's a list of default ones like HTTP title, is there any robots.txt, that sort of thing. So we're going to run all of those default scripts as well. And then the last thing it does is a trace route, which is typical networking kind of stuff. All right, so we can see here the suspects are 135, 139, and 445. So we're starting to see here, this particular one is of interest to us. So we know kind of where we're going with this. Now keep in mind, I didn't use or specify any port to scan. So by default, if I don't specify anything, it's going to scan, Nmap is going to scan the first 1,000 top ports, and it's going to be TCP. So I'm not going to find any UDP ports doing it this way. I'm not going to find, ports that are up in the 30,000 area, because it only scans the first 1,000 top ports, okay? If I want to get specific, or if I want to scan all 65,535 TCP ports, I would use TAC PTAC. And if I wanted to do any of the UDP ones, I would use SU, which would do a UDP scan. Personally, I like another tool called Unicorn Scan for that. It's a little bit quicker, but that's beyond the scope of this. So here we can see I've got 445 open, I got remote, I got RDP open there, a few other interesting ones here, but the one I want to kind of focus on is this, because if we scroll down a little bit more, the default scripts that ran did an SMB OS discovery. And then as it goes down a little further, we can see that they're using Windows 7 Professional. And we can see they're using all these SMB stuff, but we don't really know if it's actually vulnerable to the Eternal Blue one. Now, when we were looking over here, we saw this MS17010 as the number, right? So what we want to do is kind of scan for that by using a script. In this case here, to do that, you say nmap and tac script, and then we'll say vuln. What we're doing is we're picking the vuln category to do the scan of. So I'm going to go ahead and hit enter, and while it's running, let me pop over here real quick, and we're going to go over to nmap script, if I can type correctly here. And if we go to the scripting engine, I believe here, there we go. And categories is what we want. Awesome. So right here you can see, the default scripts that are listed right here. So these are different categories. You have auth, you have broadcast, you have brute, which is entirely intrusive. But then further down, you'll see another one called vuln. So they're going to run scripts that are looking for specific known vulnerabilities, which makes this tool amazing. All right, so let's come back here and see if it found anything. Okay, so it hasn't found anything yet. More than likely what will happen is that it will find MS17010, and that will hopefully show that the check shows that it's vulnerable. But we're also going to go ahead and do it in Metasploit as well. So while this is running, I'm going to bring up another tool called Metasploit. So Metasploit is an interesting tool. By the way, I'm going to change a view here. One of the things I like to do is make sure there's unlimited history in case there's a long command, but I also like to set this transparency down to nothing. I just don't like the stuff in the back. All right, so I'm going to do a tool called Metasploit. Now, Metasploit is a very well known, very well used tool in the attack, community, whether it be good guys or bad guys. It basically has all the different known published exploits in it, and it makes it kind of an automated way to do things. And it also has its own built-in command shell tool called Meterpreter, which a lot of people like to use as well. So it's very useful for what we need to do. So what we're going to do is we're going to start up this Metasploit framework. I'm using Kali Linux, and it comes installed on Kali Linux, and there's a community edition, which is free. If you want to pay for any of the Metasploit stuff, that's typically to get like reporting and statistics and things like that. So unless you're a big enterprise that wants all that, you can just stick with the free version that comes with Kali. So in this case, to tap into the database that Metasploit has, we need to make sure that the PostgreSQL is running on Kali. So to do that, we'll say service, and I always get fat finger there, PostgreSQL, and start. And then once that starts, we're then going to initiate the Metasploit database. Now, if this is the first time you're running this, it'll actually set up users under the MSF database. For me, I've already done it, but I just want to show you the command. It would be msfdb init, just like that. And it will go ahead and show it. Now, this would be in the version I'm using currently, which is the 2020 version. So just keep that in mind in case things change in the future when you look at this video. So the database is already started. We're ready to rock. So let's go ahead and bring up our MSF console, all one word. All right, while that's running, let's go back and check our nmap script, see what we got going on here. All right, so we got quite a few different things showing here. Okay, here we go. This is what we want. MS17010. Look at that. Pop, 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 pop. Another vulnerable one here ready to drop. So we can see it is exploiting the SMB1 server. Now we're going to show how to scan this as well right now using MSF, the Metasploit. So let's come back on over here to Metasploit. So usually you get some cool little graphics. Sometimes you get like a cow, or this one here we're getting some missile command version 5, all kinds of cool stuff. So the first thing you want to run to make sure that the PostgreSQL connected to the Metasploit database is db_status. And that's what you want to see, connected to MSF. Now, when I do a search, it should be fairly quick. It shouldn't take forever to search because if you didn't connect it, it would take a while to index. So in this particular one here, I want to search specifically for that MS17010. So I'll say search, and then I'll say MS17, and typically the way they'll do the wording in these are with an underscore. So I'll say 010, and we'll search and see what comes up here. All right, so we have a couple different types of modules that are in Metasploit. You have auxiliaries, you have exploits, and you also have post-exploitation ones. If I want to actually scan to see if a machine is vulnerable to Eternal Blue, which we already know from our nmap scan, but we're going to show you how to do it here as well, then I want an auxiliary right there, okay? Later we'll use this one right here. We'll use the exploit here in just a little bit, but for now, let's just do this scan first. So what you'll do is you'll copy this, and over here you can see the probability that it will run would either be normal, average, excellent, good, things like that. So the syntax for using Metasploit in this case here is you would say use, and then you would put in that full module name. In this case, we're doing the auxiliary scanner. Hit enter. Then what you want to do is you want to get some information about it, because you don't want to be a stupid script kiddie. You actually want to understand what is going on here. So let's take a peek here, and it gives you a little bit of information. Not too much, but some. When it says remote code execution, they're essentially talking about more than likely a buffer overflow to allow this to happen. Usually happening with certain ways that they create memory for certain applications. That's typically what does that. Then down here, it tells who made it. And down here, it has some basic options and some different things that you're going to be actually needing to fill out. And then down here is the description talking about how this particular thing works, how this particular exploit would work. So if you want to really get some information about it, they give you some CVE details here to look at as well, plus a variety of other different articles, which is cool. So what we want to do is we want to find out, well, what does Metasploit need from me to run this, right? What is mandated? So to do that, you type in show options. And here we can see what's required and what's not over here on the far middle. Okay, so we can see, yes, that's required, and it looks like it's already filled out. Yes is another one, our host. It looks like it's not filled out because it doesn't actually know what the remote host is in this case here. This one looks like it's filled out for the 445 port. We're good there, and the threads are good as well. So the only thing we need to fill out is the our host. So we need to do the set command. So we'll say set our host. Now this is not case sensitive, unlike some other things in Linux. This one you can do lowercase. So I'm going to say set our host, and let's go grab our IP address of the victim, in this case here, and plop that in. And then what you'll do for an auxiliary is you'll run it. So you say run, and let it run, and there we go. Host is likely vulnerable to MS17010. Awesome. So it looks like you can do a little pop, pop, pop on this bad boy and get this thing cranking. So now that we know that, let's go ahead and use one of those exploits that we saw a little bit ago. So let's come back up here, and let's use this one right here. This is our Huckleberry. Let's grab that. And we're going to do the exact same thing we did here. So you don't have to get out of any menu or any window. You can just go back and say use again, and then put the exploit in. So again, we want to figure out what does this exploit need from me. So again, we'll say show options. All right, let's see what we got here. So we need an R host again. Now, by the way, beyond the scope of this tutorial, you can set it up so that that you can set the IP address for all the remote hosts for all the exploits you're going to run. So you don't have to keep putting this in, but that's beyond the scope of what we're doing here. So our host is empty. We need that. This is needed. We already have those filled out. That's awesome. And then down here, we have payload options. So this one is doing some sort of interpreter reverse TCP. Now keep in mind this particular exploit is a little shaky. Sometimes you need to run it 5, 6 times to get it working. So we're hoping the demo gods are smiling on us today. But first, let's set our host. So we'll say our host, and then we'll put our IP address just back there. Awesome. And next thing we need to do is set up this particular local host that we actually have here. Now, if we actually are using try-hack-me, there's a tunnel address that's being used. So if you do ifconfig, this is the actual tunnel address where these connections come back to. Okay, so in this particular case, we're not looking for the ETH0 on this one. We should be looking for the TUN0 to get that reverse connection back. And that's what this is. This is a reverse connection back. When it says reverse TCP, the idea is to have the machine ask us to join it. That way we can get around a stateful firewall. So we need to set this local host. We're not too concerned about the port, but do keep in mind something interesting here is that most server admins worth their salt are knowledgeable about the fact that Meterpreter and Metasploit Meterpreter and Metasploit are very popular things being used by attackers, and typically the default port is 4444. So a good server admin will block that or at least monitor it. So you may consider changing that, but for the demo, we're fine. But let's set the local host because that's incorrect. So we'll say let set L hosts, and then we'll put in our tunnel address. Okay, let me just verify. Yep, okay, cool. And we're good with the port, so we'll keep that. Everything's good there. So that's our local host machine. We're trying to get that machine to connect back to us. Okay, I think we have everything we need to pop it. So let's go ahead and try it. We'll say run. And again, if it breaks and doesn't do anything, we'll try again. So we'll do it about 5 or 6 times because sometimes it just doesn't work. And that's just the way it is on some of these different things, especially when you try to do Windows, because Windows is pretty unstable for this sort of thing. What we should be seeing, hopefully, is a command shell. That's kind of what we're looking for. And the command prompt you may be familiar with in Windows will be, you'll see what it looks like. It's pretty familiar. So when the command prompt does, hopefully come up soon, we'll go ahead and just verify that we're in the command shell, and we'll verify if we actually are anybody worth of note. One thing that we would like to see is that we're running as NT Authority system, because that's kind of the top dog in Windows, right? So a lot more good times than some other things. So, looks like that one failed. So what I like to do when I see the first fail is I like to Control-C it and run it again until it actually works. Because again, you'll see that this will happen quite often, is that these different things will just be unstable as all get out. And if it really gets bad, we'll just restart the VM and try it again. But we'll see what happens. Okay, for now, let me pause the video in case this takes multiple times. And we'll come back and see what we got. All right, so an hour later, after multiple tries and other Python-based manual exploitation, I finally got it to trigger by switching different port numbers from the default. Also, when you set it up, apparently now, under the use exploit, it defaults to making a Windows 64 Meterpreter, but the L host is set automatically to ETH0, which is not what we want. We want TUN0, which is this one. So I had set that on that, and I just picked a random port because apparently the ones I was using, it wasn't working. I tried 7 different ports. Anyways, finally got a win and blasted in via Eternal Blue. So that's pretty sweet. So let's do a get UID, which is a command. Well, actually, before we get into that, what we got here is Meterpreter in Metasploit. This is specific to Metasploit, and it's a kind of a customized command shell type of thing, and you can do a whole slew of different things. And to find out what you can do, type in the word help like that, and you can do a variety of things with this shell. One, you can modify like timestamps on files to make it appear as if you didn't modify them at a certain date. You can dump hashes. You can try to get system authority, which on Windows is kind of top dog, and that's kind of what we want, NT authority system. Play WAV files. You can record somebody's microphone, stream their webcam from their laptop, whatever. I mean, just a slew of different things. Here's the keyloggers, steal tokens, all kinds of cool stuff. Ones we're going to use probably is this one, shell, to try to find the flag. And we'll use this one, get UID, to find out what we actually have. You can see here, get UID tells us who the server's running as. Who did I break in as, essentially. And I think we'll also use the get system to try to get, if we're not already NT authority, we'll do the get system to try to get that. Okay? All right. And we'll try to dump hashes as well, but we're going to use scripts to do that. And I'll show you that in a minute. So first, let's do a get UID. Oh, well, there we go. Pop, 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 another server drop. All right, players, it looks like we're in as top dog. I'm digging it. Pretty cool stuff. So now that we have that, what we can do is we can say run. Oops, let me do that again. Run, and then tab a couple times. Tab, 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 tab. There we go. And it's going to ask, do you want to display all the scripts that Meterpreter has? And I'll say yes. Whoa, juice. All right, so we see quite a few of them here. Like you can check if they got a VM. You can do an ARP scanner to see if there's other NIC cards on the network that we can pivot to, those sort of things. That's pretty cool. Get countermeasures for firewall stuff, all kinds of cool stuff there. We're looking for the hash dump. So let's go down a little further here. There it is, run hash dump right there. So we can run it that way, or we can run the exact script itself, which I think is under post Windows gather, but we'll try this one here and we'll see what happens. Yeah, so let's do that. Let's quit out of that, and I'll say run hash dump. There we go. All right, obtain the boot key. So it's using a particular technique here, using where it's dumping the SAM database, which is going to be holding the NTLM hashes. It was an old trick. Oh, looks like that didn't work. All right, so let's try. All right, let's try something different. So what I'm going to do is I'm going to background this session that I'm in. And the reason I want to do that is because I want to keep my Meterpreter that I have here, but I want to try to run a different exploit, because there is another one out there that we can use from the actual exploit stuff. Now, just to verify, in order to do this, we're going to need a session ID for the Meterpreter we're in. So we'll say sessions tac L, right? And what that will do is it will tell us any sessions that we have background behind this Metasploit framework main window we have here. And we can see over here on the far left, it says ID 1. That tells me the Meterpreter that I'm in is NT authority on John PC, essentially telling us that we have connected, this is my tunnel, on this port to the victim at this port. Remember I was telling you the numbers 49 or 40,000 and higher are typically going to be your ephemeral or dynamically created ports. So now that I've backgrounded this and I know the ID number, I'm going to run another search. I'm trying to remember what it is. I think it's, let me just search hash dump. I'm trying to remember what the actual name of it is. Okay, here it is. Post Windows gather hash dump. That's what we want. So let's grab that and let's say use on that, and there we go. And let's show options to see what we need here. Okay, so we just need a session. And we already know what that is. It's session 1. So anytime we're setting a parameter that we see in these options, we're going to use the set command. And again, the Metasploit one is not case sensitive. So we'll say set session 1 because that was the session we have Meterpreter on. And let's run it. See what happens. Hopefully we can get it. If not, no big deal. We still can get the flag somewhere. We can get, probably jump into command prompt and try to find the flag. Oh, there we go. Awesome. All right, so we can see now we have hashes. Now, if you're not familiar with this, what's going on here, when you store your passwords on any machine, whether it be Linux, whether it be Windows, typically what they'll do is they'll hash that password. So if I had a password or Leroy Jenkins, it'll take a hash of that. Now, the hash is a one-way function. You can't reverse engineer a hash like you can an encryption. all you can do is compare it to another hash. For instance, if I had a list, a mile long of different hashes of words in the dictionary. So I have a word, plain text, and a hash that corresponds with that word. If I were to run this hash that I see here against that list, and that hash is there in that list, then I can know what is the password because the actual plain text value is right beside it. That's how they crack passwords, okay? Or brute force them, if you will. Also, you can just use a word list, which is just all the words. You can do that as well and then try to brute force the system itself. But we're doing this offline, or we're going to try to do this offline. So the idea is that on Linux and Windows, there's a couple different ways they do things. Like the first section you see here is an older version. This is before the colons. As you can see, there's a colon separating. So this section here is going to be what they call LM, or LAN Manager, which was the old version. Now, don't forget, this is a Windows 7 professional machine that we broke it into. So it still has the active on this here. But they did away with that in the new one. As a matter of fact, actually, this 404EE right here, this is indicative of saying there is no value here. So in other words, the LM was disabled, I think, starting with Windows 7. So I think that the LM is non-existent. So that we don't care about that. This section here is what they call NTLM, and it's a mechanism in Windows that uses an MD5 version of hashing to hash its credentials. What we're going to try to do is we're going to try to grab these credentials here, put them in a text file, and we're going to use a tool called John the Ripper to see if we can crack old John's password here. All right, let's grab that. Let's see, how do we want to do this? I'm going to try all of it first. If it doesn't work, then we'll take away, we'll cut some of the other stuff, but let's try it with the whole thing. So I'm going to use a command line text editor called Nano. Okay, don't bug me about the war between Vi and Nano. I don't really care about that. So I'm going to say Nano John's PWD .txt. I'm in my root directory, by the way. And I'm going to paste in that whole thing that we see there. I'm trying to think. I don't actually need those remaining colons either. So let me get rid of those. And we'll do a Control X. What that will do is ask us, do we want to save this modified buffer? I'll say Y for yes. And I'll keep the same name and just hit Enter in this case. All right. So now we actually have that there. Now, we may need to modify it. We'll see what happens. So what we're going to do is we're going to use a tool called John the Ripper. And there's a word list location. If you do ls usr/share and word lists, you'll see there's a variety of different word lists that are here and directories too. The one we want is this bad boy right there. Okay, that's the one that a lot of people use. It's pretty famous, got a lot of stuff in it, pretty awesome stuff. So we're going to use the syntax of John, indicating John the Ripper. It's got a path variable, so we don't have to actually give the absolute path for it. We'll say John, and then we'll say tac word list equals. So we want this word list, and we're not in that directory, so we actually have to give the absolute path. So, and if you're not familiar with what absolute path is, look at my Linux for Beginners video, and I should be able to hook you up there. So word lists and rock you. Next, what we're going to do is a switch called format equals. So you can do format raw MD5, regular MD5, salted MD5. You can even do NTLM, which is what we have here. So we'll say NT, oops, just like that. And then we point it to the actual file. Now, if this doesn't work, then we'll go back and chop a few things up. But we'll go with the name of it, which was John's PWD.txt. So let's see what we get here. Boom, look at that. Pop, 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 another server drop. Loving it. So we got our password right here for John. So that was pretty quick. And that's how you crack Windows NTLM passwords, especially the older ones. Nowadays in Windows 10, they do things a little bit differently by storing a lot of this in the registry. So some of these tricks may not work these days, but either way, it's a good one. All right, so we have that, and we're good to go. Now, let's go over and get our flag. So over here, we did the cracking of the passwords. We're good on that. What we want to do is we want to jump back into our Meterpreter session. And as you recall, sessions TAC-L tells us it's ID number 1. So let's do sessions TAC-I. That's telling me to interact here with session, whatever one I put here. So I'll say 1. That should bring me back to the Meterpreter prompt. Bing, just like that. So now that we have the Meterpreter prompt, what I want to do is a command called shell, because don't forget, we're now broken into John's PC as NT authority, so we can pretty much have our way with it. This will give me the command shell for that machine. So now that I actually have the command shell, we're trying to find the flag, because if you look here at the exploit room, that is one of the thing here, find flags. So there's a bunch of different flags. We're just going to grab one for right now. But we can also find, other ones if we wanted to. But in this case here, we're just going to grab one of them just to kind of show you how to do this. And then I'll let you tack away at it. So one way that you can actually search this using Windows command prompt is you can say dir, and we know the word has flag in it somewhere, .txt. So we're going to say asterisk flag, asterisk .txt, doing a directory search for these using the wildcard format. And let's see, nothing there. Okay, let me think here how else we want to do this. Let's try using a /s at the end of it. So we'll say dir, and by the way, that mess you're seeing there is me trying to do my up arrow. Oh, this apparently doesn't work too well. Okay, let's see. Flag, asterisk, anything with .txt, and /s. Let's see if that works. Oh, there we go. All right, so we got one file there. It looks like flag2.txt under, let's see, how many files we got? 1. Awesome. So we got that one there. Let's see actually what we have here. In this direct, oh, I'm sorry, wrong one. We don't want to do that. So let's see. We're going to cd back to c colon slash. Oops, I'm sorry. C colon slash users. I'm trying to see. John should be on here. dir. Okay, let's cd over to John. And we'll do a dir here. All right, so nothing in his actual directory there, so it's probably on his desktop. So let's take a peek at his desktop. Excuse me. Nothing there. Okay, so we'll come back. And let's see. Take a look at his documents. See if anything's in there. Oops, that doesn't do tab complete, I guess. Yeah, there we go. So this flag 3, flag 2 was already up here somewhere. I think it was up here. Oh, it was way up past all this. There it is right there. Under config. So we had a flag stuffed under there. That's pretty cool. Yeah, so anyways, that's how you get those flags. Now, if you ever want to type and see these flags for the challenge, what you can do in this case is you can type in the word type, because that will display the text here in command prompt. So you can say flag3.txt, and it will give you the flag. Nice. Admin documents can be valuable. So that's where flag 2 was, I think, right? Oh, no, that's where flag 3 is. So anyways, I'll leave the rest of it to you to find flag 1. I think there were 3 flags altogether. But that's essentially how you pop a machine using Eternal Blue exploit. And we were able to go ahead and use the John the Ripper to crack the hashes. So you guys got a good idea of how that works now. So I hope you enjoyed the video. We're going to be doing more of these series where we're going to be using other exploits that we see based off of vulnerable software versions. So you'll see some more of this. You'll see some more Metasploit as well. So I hope you enjoyed it. Keep on popping, baby. See you next time.